Hey everybody, back with another Polars tutorial. So today we're going to be talking about concatenating data frames in Polars. So also known as appending or unions, depending on which data science environment you come from. So when we talk about concatenation, we're really talking about just adding rows to a data frame by stacking two data frames on top of one another. So here I have two sample data frames that we're going to try to concatenate, just some fake data of student information, just year and GPA, and the name of these students. And so when we concatenate these two data frames, there's some inconsistencies here that will cause a problem. The first inconsistency is if we look closely at this GPA column, the data types are different. So in this data frame, it's float 64. In this data frame, it's actually string. And so the next inconsistency is that this data frame, the 2025 data, has an additional column. It's a list of the sports that these hypothetical students participate in. So each of these two columns are going to cause a problem, and we'll see what that looks like once we kind of get into it here. And so this is a very short program. So if our data was actually really clean and tidy, this would actually be all the code we need. It's very easy to concatenate data in Polars. So you create a new data frame, of course, so combine, I'm calling it combined. So it's just pl or polars.concat, and then in a list, you just pass in the data frames you want to concatenate together. So here my data frames are called data 2024 and data 2025. So let's see what this looks like. Whoops. Let's see what this looks like when we concatenate them. Okay, and so we got an error. And so the first error we got was a shape error for this concatenation. And the error message says, unable to append data frame of width 3 with the data frame of width 4. And so what it's telling us is that this data frame right here has three elements, and this data frame right here has 4 columns. And it's telling us that it needs to have the exact same columns in order for the concatenation to go through. And so we could just theoretically just handle that on input here and just say drop sports. But there's another problem that we talked about before, and that will crop up if we try to concatenate these again. Okay, so now it's showing us a schema error, and it's telling us that type string is incompatible with expected type float 64. And what's a little bit unfortunate about this error message is it's not telling us which column is causing the problem. That would be very helpful for really, really big data sets with lots of columns. So you might have to do a little bit of detective work, but here we do see that it's caused by this GPA column. And so there are methods to resolve all of these in Polars. There's an option that would take care of both these issues if we read the documentation. So namely, in the documentation, we see that there is this how option, which it corresponds to concatenation method, and the default concatenation method is vertical. And vertical is basically, it means what we just saw. It means that it won't allow the concatenation to go through unless the columns are exactly the same and the data types are the same as well. If we were to use, I won't go over all these, but if we were to use diagonal relaxed, it's going to fill in null values for instances where the column names aren't the same, but it's also going to coerce columns to their supertype if they're mismatched. So it's going to attempt to resolve those type mismatches. So we'll go ahead and just take a look at that and see how our new data looks. Oh, whoops. Yeah. Okay, so there we go. So now we see that in the 2024 data, sports has been filled in with null values, which is perfectly fine. But we also notice that our GPA column has been coerced into string. So that may or may not be undesirable. It probably would be in a larger processing system. These type conversions may cause a serious problem because we may have code below that's expecting a numeric column, but here it's transforming it into a string column, so that could cause a lot of kind of detective work and just backtracking to figure out like where this type conversion took place. And so I personally feel that it's always better to resolve these type inconsistencies prior to concatenating, to just make sure that to be really disciplined and to make sure that you're not introducing any errors down the line. So I prefer to only use diagonal, and diagonal just means that it's going to find a union between the column schemas and fills in missing column values with null. So it's just going to allow concatenations to go through if the columns aren't exactly the same. So I'll just go ahead and fix the issue with column. Fix the type inconsistencies just on input here. So this is GPA. And so then the way you transform the column type into a different data type is with .cast, and then in parenthesis you just write in the pl.float 64. Okay. Okay, so there's our resulting data set. We see we have the sports column on there filled with nulls, and we have the GPA column, and it's in the desired column, which is float 64. Okay, guys, so that's how you concatenate data frames and polars. As you can see, it's quite simple, but there's a lot of kind of methods that you need to use to get the desired outcome you want. And again, the desired outcome is going to depend on what your requirements are. But definitely know what they are before you use them, and don't be too haphazard in how you go about doing it, because it can introduce data types that are inconsistent with your code at a later point. But thanks so much for watching, and I hope you have a good rest of your day.